Hello everyone, my name is Andor. Today we are going to expand our virtual reality experience inside this VR headset. You can see you are looking through two holes or two lenses which are circular, and the fabric or plastic around it is black. There are multiple examples where you extend your monitor using LEDs at the back, which lights up the background according to the color of the monitor. Today we are going to do the same, but inside the VR goggles. If you put on the goggles, you will see the black lines next to your eyes, left and right, but it is not really visible in the middle. We will use only two LEDs for the first prototype, one on each side. It is the cat. So maybe like this it will be a more immersive experience. For the most simple version, we will use two RGB LEDs and an open source software called Adrelight. Adrelight uses Arduino to control the LEDs. We will modify the Arduino code to use these two LEDs. This is the Arduino board, and we will need relatively many cables for these two. So let's get started with the assembly. The assembly is very simple. We will need two ground cables, two green, two red and two blue cables. On these modules you can see the negative pole, the blue, the green and red. On the Arduino we will use the digital output, the PWM. You can see which pin is designed for PWM. We will use 3, 5 and 6 for the left eye and 9, 10 and 11 for the right eye. First let's plug in the ground. Continue with the red, green. The last jumper cable is the blue one. It's done. You need PWM to control the brightness of each color separately. The next step will be programming the code onto the Arduino. We have to go to the Adrelight GitHub page. You can see the description, installation and things like that. Go to the release page, download the Adrelight INO and the executable setup. First try the executable. This program is not recognized by the Windows, so you have to click info and run anyway to start this software on your own risk. Currently we have one LED on the left, one LED on the right. The minimum count is 4, so it will place one on the top and one on the bottom also. I've also changed the spot width, spot height and distances to quite a high value. It will average quite a big area on the screen. On the serial communication setup, this will be the COM port of the Arduino to communicate with, and we can send random colors and enable the actual data sending. Download the Adrelight INO. This is the Arduino code. This needs to be modified in order to control these two LEDs. So this file uses the FastLED library. We won't need this. Everything which drops error according to this library we won't need, so we will basically delete them. Change the LED count to 1 and 1. The LED data pin is different because we will use PWMs. There is a message preamble. This is probably the start of the communication. These are related to the FastLED library, so we won't need them. Also these are fast LED. In this setup we need to make the pins output pins. There are 3 modes: the animation, amp light and black. Amp light is the function we are looking for. Here is the condition to enter the amp light mode. Only need this one. First we enter the animation mode, and if we will have a serial communication, change the mode to amp light, where we process the incoming data. This will send us 3 bytes, 1 for each color, and 4 times 3 bytes, 1 for each LED. We only need 2, and we don't need the last part. If the LED num is equal to 1, then it will be the left eye, else if the LED number is 3, then it is the it's not Python, right eye LED. We need to set the brightness value. It will be PWM, and the function is analog right pin, and the value is red. Similarly to the right eye, I'm sure it can be further optimized, but it is just for testing. Right, let's try to translate it. We will have some errors. What is the problem? Red was not declared in the scope, so we need to move this inside this. Fast LED was not declared, so we can delete it. It's also here. Okay, let's plug in the Arduino. And let's see if we can program it. Okay, it is programmed. Select the port and try sending data. It is working. Left eye, right eye. Let's put it in the headset and find out if it is any good. It's not working, but I can fix it. We need to put the VR view on full screen. Okay, now let's see. And it's kind of working, but it's reverse. It's actually quite responsive. Let's show you how should it work. If you look at the sky with your eye, it's blue like the sky and green like the ground. If you look at the ground, it's kind of working. Change the sky to black. You can see it's barely lighting up. So it's working. Inside, you have to be careful not to poke your eye out. Next time we will design a better one with more LEDs and maybe wireless. Thank you for following me on this journey on building this virtual reality expansion prototype. See you next time.